The deuteron is the nucleus of deuterium, which is a heavy isotope of hydrogen. Unlike ordinary hydrogen, the deuteron contains two nucleons in its nucleus. These nucleons are one proton and one neutron. Because it is the simplest nucleus containing two particles, the deuteron plays a very important role in understanding nuclear structure and nuclear interactions. In the deuteron nucleus, the proton and neutron are bound together by a very strong interaction known as the nuclear force. This force acts at extremely short distances and is responsible for holding nucleons together inside atomic nuclei. The nuclear force between the proton and neutron is strong enough to keep them bound together as a stable nuclear system. The binding energy of the deuteron is approximately 2.224 MeV, which indicates that the proton and neutron are weakly bound together. Size of the deuteron. Experiments using high-energy electron scattering show that the average radius of the deuteron is about 2.14 femtometers. The value is larger than the radius expected for heavier nuclei, which indicates that the proton and neutron are loosely bound and relatively far apart. The spin and angular momentum of the deuteron also provide important information. The proton has spin 1/2, and the neutron also has spin 1/2. When these two spins combine, they can either be parallel or anti-parallel. In the parallel case, the total spin becomes 1. In the anti-parallel case, the total spin becomes 0. Experiments show that the deuteron exists only in the parallel spin configuration, so the total spin of the deuteron ground state is 1. For the deuteron ground state, the total angular momentum quantum number is 1. This mainly corresponds to an orbital angular momentum value of 0, which is called the S state. However, experiments show that the ground state of the deuteron is not purely an S state. There is a small contribution from an orbital angular momentum value of 2, known as the D state. Therefore, the ground state of the deuteron is mostly a 3s1 state, with a small mixture of 3d1 state. This shows that nuclear forces have a tensor nature. The deuteron also has a small non-zero electric quadrupole moment, indicating that its charge distribution is slightly deformed. Another important feature is that the deuteron has only one bound state and no excited bound states. Thus, the deuteron is extremely important in the study of nuclear physics. Since it is the simplest bound nuclear system, it helps scientists understand the interaction between nucleons. Experiments involving deuterons provide valuable information about nuclear forces and nuclear structure. Conclusion. In summary, the deuteron is the simplest atomic nucleus consisting of one proton and one neutron. Its ground state properties, binding energy, and quadrupole moment provide important insights into nuclear forces and the behavior of nucleons inside atomic nuclei. For this reason, the deuteron remains a fundamental system in nuclear physics research.